It's time to talk about trigonometry, a topic that we'll be covering slightly this year, and then next year you'll be doing a ton more of. So it's really that you need to get the basis for this now. And the basis for this chapter is really founded in something you already know, which is the Pythagorean theorem, a squared plus b squared equals c squared. And I'm just going to bring this up now because if you don't know this, you won't be able to do any of this chapter at all. So what this really talks about is a triangle with a right angle like this. Now, it's a horrible drawing of a right triangle, but I put in a little box there so I can convince you that it is a right triangle. And what this is really saying is A is one of these sides, B is another side, and C is the hypotenuse, or the third side. So if you know two of the sides, you can use this formula to find the third side. So you might have this. These are the two sides. What's the value of the third side? Well, you know 7 is the hypotenuse, that's C. You know what A or B is, and you need A or B. So you got to write out the formula, a squared plus b squared equals c squared. You can obviously skip steps if you know what you're doing, but you have 4 squared is 16 plus b squared equals 49. 49 minus 16 equals b squared. B squared is 33. Take the square root of both sides. Your answer is b is equal to the square root of 33. And normally we put plus or minus, but here it doesn't really matter because we know that this distance from here to here is not a negative number, it's a positive number. So it's the square root of 33, and if you could reduce that, you would, but this is 3 times 11, which you can't take either of those out. It doesn't show up twice. Both of those are prime, neither of them shows up twice. Now, the actual thing we need to learn in this chapter, you already know about the Pythagorean theorem, we just need to refresh it. The actual thing, new stuff from this section, 13.1, is these things. We have sine, which is sin. We have cosecant, or CSC. We have cosine, or COS. We have secant, or secant. I'm just overpronouncing it so you guys know how to spell it. So secant. We have tangent. And we have cotangent. Now the interesting thing about this is, I take it from the textbook, but it says for your notebook. And we actually have notebooks that you can write this in. How cool is that? So what do these things actually mean? Well, all of these relate to a right triangle still. And what it's telling you is you can find out more about the right triangle if you know these this trigonometry. So let me get an actual right triangle here. Maybe I can drag one in from somewhere else. Okay, so looking at this right triangle, we can use these functions, sine, cosine, tangent, and these other three as well, but the basic three are sine, cosine, tangent, to find out what the lengths of these sides are going to be, or what the angles of the triangle is going to be for a right triangle. So what the first one says is sine theta. Theta is an angle that we just identify. It's not the 90-degree angle like here, but it's either this one or this one in the top right. It doesn't really matter. But sine of theta is equal to the opposite side over the hypotenuse. So that's the opposite side, the far side from the angle, depending on which way you're looking. If theta was up here, it'd be this one down here. But the opposite side over the hypotenuse. If we want to know the cosine, then it's the adjacent side over the hypotenuse, like that, adjacent over hypotenuse. Tangent is opposite side over the adjacent side. And these other ones are just flips. So cosecant is flipped of sine, secant is the flipped of cosine. See how they just flip what's on the top, what's on the bottom here? And cotangent is just the flipped of tangent. So how do we actually use these things? Let's say we have this problem. It says evaluate the 6 trigonometric functions of the angle theta. Remember, those are all the ones we talked about. Sine, cosecant, cosine, secant, tangent, cotangent. Of this angle theta, and it gives us this right triangle. The first thing you notice when you look at the right triangle is it's actually missing some information. It doesn't tell us what the hypotenuse is, and like we said in the beginning of this video, we can find that out using the Pythagorean theorem. which is what they do here. So from the Pythagorean theorem, the length of the hypotenuse is 13. Okay, good. You guys know how to find that. So now we know this side is 13. Then what do we do? Well, to find the 6 trigonometric functions, you just set up what it is. So like here's theta, and sine is equal to opposite 12 over hypotenuse 13. That's 12 over 13. Cosine is adjacent 5 divided by hypotenuse 13. Tangent's opposite 12 over adjacent 5, 12 over 5. Now, this is really easy if you can remember what they are, like what the ratios are. And the best way to remember these is the acronym Sohcahtoa. And when you see this, you're probably thinking, Sohca what? But let me make it easy for you. So Sohcahtoa is really saying that Sohca, or so, is sine, is opposite over hypotenuse. So it's just the acronym. Cosine is adjacent over hypotenuse. Tangent, or tan, is opposite over adjacent. So that tells you the basic 3, and then you have to remember which one is the flipped of that one. So you have to remember cosecant's the flip to sine, secant's the flip to cosine, cotangent's the flip of tangent. But if you can remember Sohcahtoa, this is probably like the most useful thing in all of trigonometry, and it will help you incredibly in this chapter and next year especially. Alright, so this is really where this stuff starts getting good, where it says find the value of x for the right triangle shown. We're looking at it, and we're thinking, okay, we know this angle is 30 degrees. We see an 8 is the hypotenuse, and the adjacent side is x. So shouldn't we be able to set up some equation that x is a part of? And we can. We know from Sohcahtoa that cosine of 30 degrees, that's theta, cosine of 30 degrees, equals the adjacent side, x, over the hypotenuse, 8. Remember, that's adjacent over hypotenuse, and you remember that from Sohcahtoa. And you're going to be able to solve for this. Cosine 30 equals x over 8. So let's go ahead and solve for x really fast. So let's multiply both sides by 8. And we get 8 times cosine 30 equals x. And then you stop and you say, yeah, that's great, but what's cosine 30? Well, that's when we get this thing out, and we press cosine 30 times 8. There you go. X equals 1.234. Basically, what I want you to learn from this chapter is that using sine, cosine, tangent, and the other 3, using all those 6 and knowing what they are, you can find any length of a triangle, and you can find any degree of a triangle. But we're just going to focus on length. So like here, if we want to find what A is, we have a couple choices. We know that tangent of 28 equals A over 15. That's because tangent equals opposite over adjacent. So tangent and the angle equals opposite over adjacent. That's A over B, or A over 15. So we can just say 15 times both sides. 15 times tangent 28 equals side A. And once again, I'm just going to get the calculator out and say 15 times tangent 28. Alright, so I had to stop the video and do a double take because my answer was negative 4.22. And we already know that a length can't be a negative, so I'm glad I caught this in this video. But what's actually going to happen is we have to make sure the calculator is in degree mode, because I've said tangent 28 degrees, but the calculator has a few modes, and we have to press it. So go to mode on your calculator, or else you're going to get the incorrect answer. Press mode, go to degree, press enter. Make sure it's in degree mode or this won't work. Like what I did not work. So let's make sure we have it in degree mode now. So tangent 28 degrees times 15. and it says 7.975. A equals 7.975. That's what this side is. And if we want to find what C is, we just got to pick one more thing. So I don't know, now we have B and A, so we have a couple choices. We can use sine or cosine, actually, because we have A and B. So let's just use sine. Sine is opposite over hypotenuse. That's 7.975 over C. And we want sine of 28, sorry. Sine of 28 is 7.975 over C. So in order to solve for that, we have C on the bottom, so we need to get C out of the bottom by multiplying both sides by C. So we have C sine 28 equals 7.975. Divide by sine 28. And C equals, I have to plug it in, 7.975 divided by sine 28, and it's in degree mode, so we're fine, 16.987.